Alright, here we are wrapping up Exploration 2 for Unit 1, Investigating Motions of the Sky. This time we're looking at investigating how the sun moves across the sky. With our essential question, how and why does the daily path of the sun across the sky change for different locations on Earth? The vocabulary you should have come across is the axis, which is an imaginary straight line through the center that the body rotates about. Rotate just means to spin. Revolve means to go around completely. So if you're revolving around another object, you go completely around another object. For Earth, revolving around the sun, one revolution is equal to 1 year or 365.25 days. Orbit is the path, or it means to travel the path. Either one of those, if you're talking about the noun version or the verb version. So Earth orbits the sun, or the Earth follows its orbit around the sun. Either one. The ecliptic is the path that the sun follows as it apparently moves through the sky. And for that, it starts kind of eastish and then goes up and then sets each day. Solar noon is the highest point the sun reaches in the sky. Zenith is the highest point in the sky, 90 degrees. So that's straight up if you're outside. And let's go. On to activity 1. The purpose here was to understand the apparent movement of the sun using various models of the Earth-Sun system. We spun around the room to model the Earth spinning again. We used the globe to consider when and where the sunlight would hit the Earth. It's different depending on your hemispheres. We modeled the Earth rotating around the sun using the motorized planetarium. And that was great. That was cool. How many times is it going to do that? All right. Next up, the sun appears to rise or move across the sky because the Earth is rotating, unless you're near the poles. The sun is never directly overhead at transit unless your location is between Tropic of Cancer or the Tropic of Capricorn. The angle of the Earth is 23.5. So the Tropic of Cancer is at 23.5 degrees north. Tropic of Capricorn is 23.5 degrees south. They're in alphabetical order. Cancer on top, Capricorn below. Both of them are related to that 23.5 degree tilt. The amount of time the sun is in the sky varies throughout the year and according to the location on Earth. When it's summertime in the northern hemisphere, we get a lot longer exposure to sun than we do in the wintertime. Changes in the position of Earth in its orbit and tilt of its axis over time affect the apparent path of the sun. So sometimes in the winter, specifically, the sun doesn't appear to get as high as it does during the summer. Here are some pause and reflect questions. The apparent daily path of the sun changes over the course of the year. Explain what causes this, giving examples from the models. You can pause this and read that to make sure that you have that down completely. Number 2, is the daily path of the sun the same for every location on Earth? It's definitely not. Giving examples from the models. For example, the following is true when the North Pole is tilted towards the sun. North Pole and the area around it are in constant sunlight. Right, so we sat in the stellarium where the sun just didn't go down. Meanwhile, the sun in the southern hemisphere is never there. At least for part of the year, just for one season. The sun appears to be parallel to the horizon as viewed from the surrounding area, so the path of the sun is tilted to the horizon, but it does not appear to rise and set each day. The sun reaches its zenith at transit only from Tropic of Cancer. Everywhere else, the sun is lower. We're going to actually look at what this specifically what this looks like when we get to Activity 3. Activity 2, we used stellarium to travel to the North and South Pole and the equator to gather data on the sun's altitude. This took a while because we did it every 2 weeks. This next graph is not complete, but Kira Carter, class of 2023, kindly shared it with me just to give you an idea of what you were looking for. So in this graph, you can see the sun hitting the maximum altitude June, July, and then for a different area in December. Why was the sun visible from North and South Pole? Was the sun visible from the North and South Poles on your birthday? Most people are going to say no unless your birthday is on or near September 21st or March 21st. Draw a picture. So the picture at the poles, the sun appears to move in a circle, paralleling the horizon. And this is what it looks like. I like doing this because, hey, here we go. I'm just going to go by hours. And it just apparently just keeps going in a circle. So I am at the North Pole in summertime. Just crazy, right? How does this relate to the models from Activity 1? In the models, when a pole is pointed towards the sun, Earth is rotating through one complete day, doesn't change the relationship between the pole and the light source. 4. What is the highest altitude the sun reached in the sky at transit as viewed from the equator, the lowest? The highest it's going to get is 90 degrees. The lowest it's going to get is 66.56. Based on our class data, when was the North Pole tilted towards the sun? That happens from late March to late September. Summertime, right? This, coincidentally, happens when we are farther from the Earth, from the sun, excuse me. So when we're farthest from the sun, the Earth is going to be tilted towards the sun. Did your class data include any for which the sun was visible from both poles? If they did, it was going to be, again, around those equinox, the spring equinox, March 21st, and the autumnal equinox, September 21st. When was the sun farthest from the north? I just talked about that. Farthest, June 21st, and farthest south around December 21st. When is the sun directly overhead at the equator? Again, the equinox. So we have this